Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good morning, student.
Morning, Miss.
Morning, Miss.
How are you today?
I'm fine, thank you, Miss.
And how are you, Miss?
I'm fine too. Thank you, Kartina. Before we start the lesson, let's say a prayer together. Lutfira, will you lead the prayer, please?
Yes, I will, Miss. Okay, before we start our lesson, let's pray together. Amin. Finished.
Okay, thank you, Lutfira. Is everyone here?
Present, Miss.
Okay, Miss will be absent one by one. Please open the camera when the called. One, Kartina.
Present, Miss.
Lutfira Eka Putri.
Ready, Miss.
Nurul Hardianti.
Yes, Miss, I'm here.
Alhamdulillah, everyone is here. Miss hope we are the given health during the current pandemic and take today listen well. Miss will give one motivation for today, namely from Walt Disney, which is if you can dream it, you can do it. So Miss hope we can be enthusiastic and keep trying. The will enter today, listen today. Today we will discuss about editation polymerization because the topic is broad. Miss will only discuss some of the them, namely polyethylene and polychloroethane or PVC. Miss will divide of this discussion into two parts. We will talk about polyethylene, then we will discuss about polychloroethane. Here, Mill asks Nurul, what is the mean by editation polymerization?
Addition polymerization or chain reaction polymerization requires two monomers to have at least one double bond.
Right, that's good, Nurul. Anyone else want to answer?
I'm Miss.
Okay.
In polymer chemistry, an addition polymer is a polymer that formed by simple linking of monomer without the CO generation of other product.
Okay, thank you, Kartina. And Miss, in polymerization, in editation polymerization, monomer reacts to form a polymer without the formation of the byproduct. Edition polymerization usually are the carried or is the presence of catalyst, which is in certain cases exert control over structural detail that have important effect on the properties of the polymer. Can anyone explain about this picture?
I can, Miss.
Okay, please answer, Lutfira.
Alkane is the fact that it has a carbon's double bond, like we can see here between the two carbon atoms. And because of this double bond, we say that alkenes are unsaturated, and under the right condition, the double bond can break into single bond, which allows the two carbons to form new bonds.
Okay, good job. So, to form a polymer of molecule, the double carbon to carbon bond are the broken to form single bond. Another importance aspect is the open bond at the bond end of polymer to allow for a more linking of molecule to change from a double bond to a single bond. Does anyone know an example of addition polymerization?
Permission to answer, Miss.
Okay, Nurul.
Addition polymers include polystyrene, polyethylene, polyacrylate, and methacrylate.
Absolute correct. It can be seen in the figure the example of addition polymerization. Monomer name and common name. Ethane or polyethylene, phenylchlorine or polyphenylchlorine, styrene or polystyrene, acrylchlorine or orlon, propane or polypropylene, methyl methacrylate or polyglass, tetrafluoroethane or Teflon. Next, which polymer are the formed by addition polymerization? Anybody know?
Polyethylene, polyphenyl chloride or PVC,
Okay. What do Kartina think about neural answer?
Correct answer from Nurul, Miss.
Okay, good. Some of the plastic made by addition polymerization include the polyethylene, polyphenylchlorine on PVC, acrylic, polystyrene, and polyoxymethyl or acetal. Next, we go to polyethylene. Polyethylene or polyethylene, abbreviated PA, UPAC name polyethylene or poly, is the most common plastic in use today. It is a polymer primarily used for packaging. Does anyone know example of SDPE?
Bottle mill, Miss.
Bottle shampoo, Miss.
Good example of HDPE, milk bottle, bleach, cleaner, and the most sample bottle. What is example of LDPE?
bin liners, Miss.
That is one the example mentioned by Nurul. It can be seen in the PowerPoint that example LDPE in carrier bag, bin liner, and packaging film. Type of the polyethylene, one LDPE, HDPE, itu the Higgs density, LLDPE, linear low density, LDPE, low density, and last, high pressure copolymers. That is, it can be seen in the use of the HDPE is the most widely used from years to years. Developed word demand will the continue while the be supported by interpret desert level of the growth stimulus, more eating at home, and the greater hackness need will the future underpin consumpted. And the developing world outside China will see bad years. China grow will the moderate slightly as the local products sharply, especially HDPE, and the hour of the current ICH chance of the short downward correction. What are the uses of polyethylene? The primary uses of the polyethylene are in packaging film, garbage bags, grocery bags, insulation of wires and cables, agricultural mulch, bottle, toys, and houseware. Polyethylene is the also used dry fruit juice container, meat container, crates, and the food packaging product. Does anyone know what can be avoided by impact of using polyethylene product?
Land and air, Miss.
Okay, good job, Kartina.
Ecosystem, Miss.
Okay, good job, Nurul. Kartina can explain what can happen to the land if the polyethylene is used?
Impact on land accumulation of polyethylene was in the soil will result in for soil aeration and for absorption of water and nutrition.
Okay, next Lutfira can explain what can to the water if polyethylene is used.
Impact on water turtles, whales, and seabirds mistake this polyethylene waste for food or get entangled in it, resulting in painful injuries or even deathness.
Okay, next Miss will explain impact on air. The burnish of the polyethylene was the product's unpleasant and the cooking smell. Impact on ecosystem health. This animal with the plastic bag in the their stomach. Fish littering typhoon default. This a common skin. Next, recycle. Polyethylene does not biodegrade unless free oxidized. Polyolefins are the highly susceptible to photooxidation or oxidation caused by the exposure to light. Hydrogenated aniline like the stabilization then used to prevent photooxidation. Uh, then we go to next discussion, namely in polychloroethane. Polychloroethane, usually known as polyphenol chlorine or just PVC, is the most versatile and plastic after the polyethylene. The most widely used, the priority of the comes from its ability to be formulated with different additives and with different molecule plastic that ranges from rigid to pliable. Polychloroethane is example of addition polymerisation. Does anyone know what polychloroethane is?
Permission to answer, Miss.
Okay, Nurul.
Permission to continue.
Okay, Nurul.
The old name for polychloroethane was polyphenol chloride, hence the use of the commercial name PVC, and is made from polymerizing the monomer chloroethane, CH2, into CHCl, old name phenyl chloride.
Okay, good job, Nurul. Can be seen in the picture PowerPoint of very long chains. Polychloroethane polymer or PVC molecule consisting essentially of the hundreds of the thousands of CH2 CHCl chloroethane units of the joined together. The ball and stick type model and the on top is the look strike. Its reality, the long molecules are the jumbled up, the chlorine atoms are so has ordered arrangements, but the more randomly distributed down the CCC depending on the which direction the chloroethane molecule is added. Polychloroethane is used to make a wide range of the things include gathering, plastic window, electrical cable insulation, sheet material for flooring and other uses, footwear, clothing, and so on. You can see in this diagram of the global plastic market, and the diagram is used film and seat, profile and tabling, wearing and covers and pipes. That's the use of the pipe in the most often used. Thus, Cortina now.
I don't know, Miss.
Okay, wait, yeah, let's stop for a moment because of the call of prayer. Okay, next ya. Does Cardinal know what the environmental impact of PVC?
I don't know, Miss.
Okay, Cortina, it's okay. We are the box studying in here. Does anyone else know the answer?
I know, Miss.
Okay, Lutfira.
In the production of PVC, many thousands of tons per year of the feedstocks, ethylene dichloride or EDC and vinyl chloride monomer or VCM are released into the workplace and into local environments. PVC feedstocks cause cancer and other health impacts. Damis,
Okay, good job, Lutfira. Due to environmental constraints, use of the PVC is is discredited by some local authorities in the countries such as Germany and the Netherlands. This concurs but flexible PVC and rack UPVC as not only the participants in the PVC are the problem but also the emission from the manufacturing and disposal. Many vinyl products contain additional chemicals to change the chemical consistency of the product. Some of the space additional chemicals cannot the additivities can lead of the final product. Plastic scissors that must be added to make PVC flexible have been added of the particular cancer. Before we go into the training video, is there anything you want to ask from the discussion that we have discussion?
Permission to ask, Miss.
Okay, Cortina.
What's the difference between polyethylene and PVC, Miss?
Okay, polyethylene is a polymer of ethylene, non-toxic, easy to radiations, fire resistant, cold resistant, good electrical insulation. It is a subtle for packaging food and medicines, making tableware, medical equipment, but also for the insulation of the electronic industry, or polyphenol chloride, which stands for PVC. It's a polymer of phenyl chloride. Chemical is stable of the resins to acids, alkalis, and some chemical. It is resistant to moisture, aging, and the flame. When used, temperature cannot exclude and the harder and low temperature. Does anyone have any more questions?
No, Miss.
Miss.
Okay, if there are the more questions, let's continue with the learning video. I hope you can listen well because later Mel will ask questions after waiting the video.
Today, plastics are everywhere. All of this plastic originated from one small object that isn't even made of plastic. For centuries, billiard balls were made of ivory from elephant tusks. But when excessive hunting caused elephant populations to decline in the 19th century, billiard balls makers began to look for alternatives, offering huge rewards. So in 1863, an American named John Wesley Hyatt took up the challenge. Over the next 5 years, he invented a new material called celluloid, made from cellulose, a compound found in wood and straw. Hyatt soon discovered celluloid couldn't solve the billiard ball problem. The material wasn't heavy enough and didn't bounce quite right, but it could be tinted and patterned to mimic more expensive materials like coral, tortoiseshell, amber, and mother of pearl. He had created what became known as the first plastic. The word plastic can describe any material made of polymers, which are just large molecules consisting of the same repeating subunit. This includes all human-made plastics, as well as many of the materials found in living things. But in general, when people refer to plastics, they're referring to synthetic materials. The unifying feature of these is that they start out soft and malleable and can be molded into a particular shape. Despite taking the prize as the first official plastic, celluloid was highly flammable, which made production risky. So inventors began to hunt for alternatives. In 1907, a chemist combined phenol, a waste product of coal tar, and formaldehyde, creating a hardy new polymer called Bakelite. Bakelite was much less flammable than celluloid, and the raw materials used to make it were more readily available. Bakelite was only the beginning. In the 1920s, researchers first commercially developed polystyrene, a spongy plastic used in insulation. Soon after came polyvinyl chloride, or vinyl, which was flexible yet hardy. Acrylics created transparent, shatterproof panels that mimicked glass. And in the 1930s, nylon took center stage, a polymer designed to mimic silk, but with many times its strength. Starting in 1933, polyethylene became one of the most versatile plastics, still used today to make everything from grocery bags to shampoo bottles to bulletproof vests. New manufacturing technologies accompanied this explosion of materials. The invention of a technique called injection molding made it possible to insert melted plastics into molds of any shape where they would rapidly harden. This created possibilities for products in new varieties and shapes, and a way to inexpensively and rapidly produce plastics at scale. Scientists hoped this economical new material would make items that once had been unaffordable accessible to more people. Instead, plastics were pushed into service in World War II. During the war, plastic production in the United States quadrupled. Soldiers wore new plastic helmet liners and water-resistant vinyl raincoats. Pilots sat in cockpits made of plexiglass, a shatterproof plastic, and relied on parachutes made of resilient nylon. Afterwards, plastic manufacturing companies that had sprung up during wartime turned their attention to consumer products. Plastics began to replace other materials like wood, glass, and fabric in furniture, clothing, shoes, televisions, and radios. Versatile plastics opened up possibilities for packaging, mainly designed to keep food and other products fresh for longer. Suddenly, there were plastic garbage bags, stretchy plastic wrap, squeezable plastic bottles, takeaway cartons, and plastic containers for fruit, vegetables, and meat. Within just a few decades, this multifaceted material ushered in what became known as the plastics century. While the plastics century brought convenience and cost effectiveness, it also created staggering environmental problems. Many plastics are made of non-renewable resources, and plastic packaging was designed to be single-use, but some plastics take centuries to decompose, creating a huge buildup of waste. This century, we'll have to concentrate our innovations on addressing those problems by reducing plastic use, developing biodegradable plastics, and finding new ways to recycle existing plastic. So where do you come in? Visit ed.ted.com/endwaste to learn more about our global.
Okay. Okay, try Lutfira explain what the lesson from the video that has been seen.
All of this plastic originated from one small object that isn't even made of plastic. The word plastic can describe any material made of polymers, which are just the large molecules consisting of the same repeating subunit.
Okay, stop Lutfira. Next, Kartina, what do you know?
What I remember from the video is in the 1920s, research first commercially developed polystyrene, a strong plastic used in insulation. Soon after came polyvinyl chloride or vinyl, which was flexible yet hardy, acrylic transparent, shatterproof panel the mimicked glass.
Okay, good job, Kartina. Last, Nurul.
Polyethylene became one of the most versatile plastic still used today to make everything from grocery bags to shampoo bottle to bulletproof vests.
Okay, very good. So I can decide the presence of plastic garbage, street plastic wraps, square-based plastic bottle, takeaway carton, and plastic container for fruit, vegetable, and meat. In this field becomes this multifaceted material. Usually, it becomes to be known as the plastic country. Well, the plastic country broke the convention, and the cost effective is the also creates surplusing environmental problems. Many plastic are the made from non renewable resources, and the plastic packaging is designed for a single use, but some plastic takes contrary to the decompose grades a huge pile of garbage. This contrary the most focus of innovation on addressing this problem by recording the use of plastic, developing biodegradable plastic, and find a new way to recycle exploiting plastic. Now let's go to example question. A drinking bottle include in PVC or polyethylene?
Polyethylene, Miss.
Okay, good. Bottle milk?
Polyethylene, Miss.
Okay, good job. Is there any wrong answers?
No, Miss.
Okay, next, coach.
Polyethylene, Miss.
What's about the other? Is Debbie answer correct?
Wrong, Miss. The correct answer is PVC.
Okay, PVC. Okay, good. Next, pipes. Next.
PVC, Miss.
PVC, Miss.
Miss.
Oh, next, plastic bag.
Polyethylene, Miss.
Polyethylene,
Okay.
Miss.
Rubber glue.
PVC, Miss.
Does anyone know why plastic bag go into polyethylene?
Polyethylene is a very versatile plastic. So because a plastic bag can be used for anything, it belongs to polyethylene, Miss.
Good answer, Vera. Miss asking Nurul to draw conclusions for our lesson today. Okay, Nurul?
Okay, Miss. Addition polymerization or chain reaction polymerization requires the monomers to have at least one double bond. Polyethylene, also known as polyethylene or polyethylene, is one of the most commonly used plastic in the world. Environmental impacts of polyethylene product, land, water, ecosystem have polychloroethylene, usually known as polyvinyl chloride or just PVC, is the most versatile plastic, and after polyethylene, the most widely used, Miss.
Okay, thank you, Nurul, for the consolation of so that are to the lesson. See you soon, and hopefully what they learned today will be useful in the future. Kartina, please lead the fire.
Okay, Miss. Let's pray together. Pray finish.
Okay, thank you, Kartina. This will give you a worksheet. You can see it in the Google Classroom. Miss hope you collect according the deadline that has been given. Okay, thank you for today. Thank you, everyone. See you next time.
Thank
Thank
you,
you,
Miss.
Miss.
See you, Miss. See you.